All right, let's begin. Good evening, everyone. Welcome to today's class. Today, we will deal with a topic that most researchers find uncomfortable or are scared of. We're going to deal with parametric statistics. In the KV Patale, it is most researchers I have met are uncomfortable. Those of us who have dealt with statistics before, you know that in college, typically in every batch there will be one or two people who like statistics and are good at statistics. So all the statistical work will be outsourced to those two people. That is typically what happens. But today, what we're going to do is one, I want to assure you, there's nothing to fear. We are going to try, for those of you who don't know any statistics at all, we will try and make it a little easier. Those of us who have experience with statistics, this will only be a refresher. So, welcome to today's session. I'll give you a warning up front. Statistics is not an easy subject. Sometimes it can be a little dry. But like I said, if you feel like you're falling asleep, we will serve some virtual coffee today, and let us see how we can make the best of it. Okay. So, from a psychologist, today's learning objectives are primarily we will understand what are the basic tenets of parametric statistics. What does it mean? The second thing we are going to do from our material is identify the basic statistical tests and how they are used. The third is we are going to learn how psychologists will use these statistical tests and data. So these are our three broad learning objectives. The presentation I have made is based on chapter 11. So, and a few extras. Now, examples konja extras but otherwise, this is largely from the material. So, at the outset, these are the foundational tools when we are comparing data. Now, as a ninga yosichikala that as psychologists, we will primarily deal with counseling, we will deal with people. And yes, that is true. But as a good psychologist, at any time, if you are going to publish a paper or you are going to do a study, unga counseling practice will yield data. And that data can be used, those of you who want to pursue a PhD or who want to get into the research side, it is very useful to know, to have a basic grasp of statistics. So the tools that we use are called parametric statistics. So what does it mean? Two big words. So let us understand what those big words are. So one assumption when we come to parametric statistics is that data should be well behaved, like a very smooth highway. You will find in the practical world, data is not well behaved. You have to clean the data. So let us see how to proceed now. So today's training agenda, the timings may differ, but we will look at the basic concepts, the t-test, ANOVA, correlation, and regression. These are the four primary tests. Then we will look at the exam perspective, and we have about 10 minutes or 15 minutes of spillover time if we have any questions or if a certain topic takes a long time. Let's start with the basic concepts. Basic concepts, as a psychologist, நீங்க ஒரு ஸ்டடி இல்லைன்னா ஒரு சர்வே அண்டர்டேக் பண்ணும்போது யூ கேனாட் சர்வே எவ்ரிபடி. For example, in our A24 batch, we may have some 400 individuals. Anna, if you want to find out the batch sentiment, how we feel about the course, it is not practical to contact all 400 of us. So what is the wise move is to contact a representative sample. You cannot survey the entire population. That is called a census. But when you want an opinion, for example, as Suleiman sir and I were just talking about the traffic situation in Chennai, for example, if we have to ask, what must we do to improve the road stretch between, say, Central and Adayar? What must we do to improve the traffic? Can we ask everybody who travels on the road? Of course not. So we ask a representative sample. So there is a population, two concepts. There is a population and there is a sample. A sample is a few people drawn from the population who represent the population. So parametric tests are like using a well-paved road. They are based on certain assumptions. Why? Because they answer a question. The question is, does this data which we get, does it represent the general population? For example, if we are doing a study on depression in adolescents, we get some data, survey data, interview data, we get various types of qualitative and quantitative data. The question you are going to answer is, does this data represent the population well enough to make a reasonable inference? That means if I say that depression in adolescents is primarily due to mobile use, if that is my hypothesis, is that data going good enough to represent such a hypothesis? That is the question. So parametric statistics deals with the population. That is, population is defined as a group of phenomena or individuals that have some common features. A sample is a small group of members of that population who represent that population. They are selected based on various criteria. Now here is the definition of a parametric statistic. A parameter relates to the population. A statistic relates to the sample. So at a very basic level, parametric statistics is a way of scientifically relating populations and small samples in a meaningful way. Now, parametric statistics is not, as many of you know, it is not exclusive to psychology. வேற ஃபீல்ட்ஸ்லயும் இருக்கு. In engineering, in fact, my discipline was in process improvement. In process improvement, we use a lot of parametric statistics. So parametric statistics is even used in நீங்க ஐபிஎல் பார்க்கும்போது you will see screenல run rate, the wagon wheel, all those are results of parametric statistics. All those are parametric statistics based on analysis. So any questions on this slide? Are we clear on the basics? Okay, so now we will serve you your coffee. I hope you have your coffee cup ready, your mental coffee cup. This is a virtual cup of coffee. Now, there are two concepts we need to understand. One is statistics. What are the types of statistics? There are two kinds of statistics. One is descriptive statistics. These are statistics that describe the details of the data. What is the range of the data, from where to where? what is the average of the data, how much does it vary, and all those mathematical calculations come under descriptive statistics. Inferential statistics, as the term suggests, they help you infer results from a sample and apply it to a population or in relation to the population. For example, how many people, I survey a group, a small group, and I ask them how many people in Bangalore are bad drivers. Chances are you will get 100%. Right? So that is an inference that we are making. Right? So these are the differences. So descriptive statistics use mean, median, mode, standard deviation, various measures. Inferential statistics have the t-test, regression, and others we are going to study today. Now to the coffee. How many cups? The question is, how many cups of filter coffee does a typical person drink in a day? Does anybody want to confess how many cups of coffee you drink in a day? Anybody? Please unmute and tell me on average. Or you can put it in chat if you don't.
One. I take only one.
Okay, one. Excellent. You are more disciplined than all of us. Anybody more than 3? We are very disciplined people here.
I take minimum 4 teas.
Super. You must be awake 24 hours a day.
Bad boy, Suleiman.
Wow. So
so that's how the marketing goes.
Good. I am also in marketing, so I understand your predicament completely. Yes, we have 2 cups a day. 2 cups a day is Indians is the benchmark for being an Indian. So Carolyn ma'am, doesn't mean you're not an Indian. It means we are progressing towards 2 cups of coffee. Anyway, whatever number of cups of coffee you drink in a day, univariate analysis refers to that. So how many cups you are analyzing one variable? How many cups? It can be 1, 2, 1.5, 2.5, whatever the number, but you are analyzing only one variable. Bivariate analysis, it analyzes the relationship between 2 variables. For example, is there a relationship between a person's age and the number of cups of filter coffee that they drink in a day? People have researched everything. So there are studies to indicate that as people grow older, the number of cups they drink based on certain factors tends to decrease. As we just now discussed, people in certain industries, advertising, marketing, which require alertness or intense effort for long hours, doctors may drink more number of cups. There you are analyzing, if you are analyzing age and number of cups, you are analyzing 2 variables. Now, when you are multivariate analysis deals with many variables. What are all the factors that predict the number of cups of coffee a person drinks in a day? It could be their job is one factor, age is another factor, the price of the coffee is another factor, where they live is another factor, right? So that when you analyze that is multivariate analysis. So now, what do we do with these things? Now we come to that they are tested using various tests. So here we will find that in our textbook, it begins with actually ANOVA, but I have actually begun with the t-test because the t-test is the beginning of these of this, basically of any kind of statistical testing, is something that we always begin with a t-test. So let us look at the t-test. So first, we will look at what does the t-test do. So does everybody know what the mean is in statistics? Is everybody familiar with what a mean is? If so,
Average.
yes. So roughly, you can say it is the average, right? So here, what the t-test does is that it compares the means of two groups, and it identifies whether the scores differ significantly. But before that, it asks an important question. Is this difference real, or is it a chance? Right? Is it depending on some factor that we have not accounted for? Has a chance just happened? This occurs, so here we will take two examples. There are two types of t-tests. One is an independent t-test, which is between two different groups, and a paired t-test, which is the same group in two different situations. So from psychology, here is an example. One is you compare the average IQ scores of boys versus girls in a classroom, right? An everyday example is you taste two coffee brands to see which one is rated higher, and you give a rating on a scale, and you compare the average score across by many people. So independent t-tests will check whether the average IQ will check, is there a real difference? Now, a paired t-test is the same group in two different situations. In psychology, for example, we measure the anxiety level of patients before and after CBT therapy by a standardized test. And another more common example is you check your weight before and after you join the gym. If you are like me, what will happen is before you join the gym, you will have a weight. Then after you join the gym, to your great dismay, you will find that you've gained weight after the first 2 weeks of joining the gym. And many people will feel that the gym is not working and quit the gym. In fact, if you may lose a little weight, the truth is you will gain weight because muscle is heavier than fat. But of course, that is a different discussion for a different course. Here, the t-test, a paired t-test, checks whether weight before and after something, any kind of therapy or any kind of intervention. You will use scores on standardized tests to evaluate. So this comes with certain assumptions. One, the data has to have a normal distribution. Normal distribution means it has to follow a certain curve called a bell-shaped curve. That means most of the extremes will be very small values. Most of the people will fall somewhere in the middle. That is called a normal distribution. Secondly, the data has to be homogeneous. In this case, the spread of IQ scores should be roughly the same for boys and girls. Right? You cannot take, a class. You cannot take boys from, the say highly intelligent group and take girls from a different group and then say compare the two and try to analyze. That will not give you the right data and the right result. Thirdly, data must be continuous data on the interval or ratio scale. So these assumptions, these are called assumptions. But in reality, when you are doing research, a lot of work goes into making this data, cleaning the data, selecting the sources of data to make these assumptions come true before we can go into the test itself. So I hope I'm clear here. Let us proceed. So when you do a t-test, so has everybody understood what a null hypothesis and alternate hypothesis is from the earlier classes? It is very important to understand the difference. And it is very important to repeat, because sometimes we will get confused. It's very important that you repeat and go back and learn what a null hypothesis and an alternative hypothesis is. So the t-test, what you must look for. First, you will measure the means and you will check, is IQ of the boys and girls different? Are the anxiety levels different before and after the therapy? And you will apply a formula. That formula will yield a p-value, and degrees of freedom. So how do you interpret that? If the t value is large, it means the difference, that is the difference between the IQ of, say, boys and girls, or difference anxiety before and after therapy, is a real difference. It is not just by chance. Important concept to also remember is the p-value. A p-value, if it is less than 0.05%, sorry, less than 0.05, you reject the null hypothesis. So you start off with a null hypothesis saying, I have this data for anxiety level before and after therapy. I am saying my null hypothesis is there is no difference between before and after, or there is no difference between the IQ of boys and girls. I start off saying, let us let us think like there is no difference. The alternative hypothesis is there is a difference. That's all. Not how much is the difference, what are the factors causing the difference. That will come from your analysis. But for now, there is no difference, there is a difference. That is all. The p-value, if it is less than 0.5, it tells you there is something surprising. You say there is no difference between anxiety score before or after therapy. But p-value of less than 0.05 means something surprising has happened. That means there is a difference. So you reject your null hypothesis and follow your alternate hypothesis. Right? So based on that, you will take further steps to find the root cause and things like that. But if your p-value is greater than 0.5, it basically says too many other factors, maybe the data is not fully clean, there's too much chance, so we will not take a chance. So you fail to reject the null hypothesis. You say there is no difference between the IQ of boys and girls, and you close your study. Right? So the direction of difference, it is a minor parameter which we will explore in other tests. So the formula, the typical formula, there are 3 formulae for the t-test. I will not go into the details of this. I will share this PPT. What I have done is I have taken the textbook and explained the formula parameter by parameter in a simple way. Right? So for example, if it says, like for example, if you look at the second formula, right, standard error, right? So it talks about standard deviation, what is sample size. These are basically a short explanation I have given. From an exam perspective, it is important to learn these formulas if we are asked to calculate. Right? So we will not go into the details of it. I will share this, but these are how when you get data, that prepared data, this data, it should tell you how to take. And so some of the skills you must know is how to take the mean, find the mean, median, mode of any data that is given. Mode, for example, I'll give you an example. When you want to find out in a company, if you want to find out what the salary is that they are offering for a certain that they're offering, You cannot take the CEO's salary, the highest and the lowest salary, and take an average. Why? Because the CEO may be earning crores. An entry-level employee may be earning thousands. The CEO's data will skew the salary. It will make the salary look maybe bigger than it is. So there you choose the most common salary in the company. That's called the mode, for example, right? Or you may choose the median, that is the middle point. So like that, there are, so it's important for us, if you're going into research, to understand the measures of central tendency. That will help you understand these things like standard deviation, sample size. These are terms that it is important for us to understand. Now, so far, have we got somewhat of an idea of what a t-test is? A basic idea?
Yes. Yeah.
Okay. All right. Now let us look at, so in essence, your t-test, there are two kinds of t-test. One will be, is two separate groups. You are comparing the mean for two separate groups. For a paired t-test, you are comparing the same group before and after, measuring twice. So this t-test is for two groups. But what if you have three groups? That is where you go to ANOVA. So if you are, for example, evaluating three groups of students, child counselors, you are evaluating three groups of students. So if you are comparing three or more independent groups and factors, you have something called ANOVA. ANOVA stands for Analysis of Variance. So here again, you have two types. You have a one-way ANOVA, that is, you compare three groups based on one factor. Two-way ANOVA is you test interaction between factors. So from psychology, an example is you compare stress levels across low, medium, and high, or individuals or students of low, medium, and high socioeconomic status. Now, the causes of stress for each individual of a different status may be different, but what you are comparing is stress levels or anxiety scores. They may be anxious for different reasons, but you can use ANOVA to compare the stress levels across three. You compare one factor across three groups. An everyday example. For example, you compare test scores of children who studied online, offline, and hybrid methods. You would use an ANOVA. So anywhere where you have more than two groups and you have one factor that you are comparing them on, you will use ANOVA. Two-way ANOVA will, for example, talk if you want to make student adjustment levels or adjustment type based on gender and family type. You're answering the question, are male students from joint families better adjusted than male students from nuclear families? So or female students from joint families. See, there are multiple parameters you are dealing with. So when you gather data, you will use ANOVA to analyze this. Or for example, everyday example is meal type, whether vegetarian or non-vegetarian, active or sedentary lifestyle. What is the effect of those groups on overall health? You would use ANOVA to analyze. So ANOVA tells us whether a difference exists. It doesn't tell us it is in this group or it is in that group. It just tells you yes, there is a difference between these groups. You will need additional post hoc tests, or you may use a t-test. That is why in our textbook, t-test is given after ANOVA, because you will need it before or after. So t-tests help you narrow down. Now, so just to understand, to give you some clarity, if you have data, this is what is called a bell curve, where and these are data for any parameter. For example, score could be anxiety levels, right? And you have 3 groups. You will look at the variation within a group. You see the green curve. Within the group, what is the variation in anxiety? And between the groups, what is the mean of each group? You will analyze the variance. That is why it is called ANOVA, analysis of variance within a group and between groups. So that is what ANOVA does. So similarly, what do you look for? What do you ANOVA tell us? It tells us whether 3 or more group, the mean value of the group differs significantly. For example, do students from different socioeconomic status differ in anxiety scores? Does it or not? That's all. So the output of when you do an ANOVA calculation, it will output what is called an F value. That is a ratio between the group variance, between group variance. Remember what we saw here, between the 2 groups divided by within the 2 groups variation. That outputs a value called an F value. And of course, you have our good old friend P value. Those of you who are in statistical analysis, for you, P value is your best friend. Everything is about P value. P value less than 0.5, you reject the null hypothesis. This is a standard rule. So now everything is in context of the hypothesis. What is your hypothesis in any situation? So here for ANOVA, the hypothesis is all group means are equal. So if the F value is very large, that is the ratio of the variances is very large, and the P is less than 0.05, that means at least one of the groups is different from the others. That's all it is telling you. It doesn't tell you which group is different. It just tells you one group is different. So it will say, okay, that means there is some. So what does that mean in practical terms? If you are analyzing anxiety scores, it means there is one group where the anxiety scores are much higher or much lower than the other 2 groups. And our job as psychologists is to research and find out. Then we will get into which group. Then we will get into why. So for that, there are other tools. But ANOVA enables, so what it is doing, it is these tools are helping us narrow down using good quality data, which is necessary if you are going to present a paper, or even if you are doing a thesis. When you present, you will be quizzed on these things. Where did your data come from? What is the validity of your data, the credibility of your data? Because I can tell you, I work with a lot of postdoc researchers, and I can tell you that a lot of people fake data. They manufacture data, and when they are asked to prove it, they will find it very difficult. So these tests narrow it down. So there is something called Tukey's HSD. These are post hoc tests after ANOVA to narrow down. So two-way ANOVA. Two-way ANOVA is between what? It's multiple factors, multiple factors affecting something, right? So what does it two-way ANOVA tell us? Whether there are main effects, that is each factor affecting something, and interaction effects. So in a simple example, stress levels. Does gender affect stress? Are women more stressed than men? Does joint family or nuclear family affect stress? Are women in joint families more stressed than women in nuclear families? Right? Like that, combinations. Are men in nuclear families more stressed than women in joint families? You see, there are so many permutations and combinations. ANOVA helps you look at which of these combinations, it helps you narrow down on these combinations so that you can come up with solve a specific problem. Or maybe you will adapt CBT therapy for women in joint families. Or maybe you will create an intervention for children or men in joint families, right? So this helps us solve certain problems. So what the output of a two-way ANOVA is, typically you will get multiple F values. In one-way ANOVA, you will get a single F value. Here you will get multiple F values, and it will talk about differences across the factors. Same way as in the one-way ANOVA, as in any test, statistical test, each F value with a P less than 0.05 means there's a significant effect. Reject the null hypothesis. If it is greater than 0.05, you fail to reject the null hypothesis. Right? So it tells us that if you get a significant interaction in a group, it means that the combination of, in our example, gender and family type significantly affect stress levels. So you can come to that conclusion based on further research. So this is primarily ANOVA. Now, ANOVA depends on certain assumptions. All these assumptions we need to take into account when we are collecting data. This is very, very important. You must make sure that from an exam perspective, we must learn these assumptions, because they will ask. ANOVA is one of the most common questions in our right throughout the years, even in the new under the semester scheme, even before that. It is one of the most fundamental questions you will get. So we can memorize this chapter if necessary. So ANOVA two-way, these assumptions apply only to two-way ANOVA, not to one-way. The assumptions are your outcome should be measured on a continuous scale, not discrete, not this or that, on a continuous scale. Like, for example, test scores, temperature, weight, those kind of things that are continuous. Secondly, the predictor variable, the variables that you use, the treatment that you use, the therapy that you use, or the gender that you use should be able to categorize it. Male or female, CBT or psychodynamic, things like that. Now, independent observation. Each participant or observation should only belong to one group. You cannot have people who are in both groups. Normally distributed data, this is typically taken care of by your software. Your data should be normalized. Now, I think there are newer models now which account for non-normal data. There are ways to deal with that, but that's not in the purview of our syllabus. No outliers, extreme values, right? So if you are studying, you have normal values and suddenly there's an extreme outlier. The process is you look at the outlier, explain it, document your explanation, and eliminate it. So otherwise, extreme outliers contaminate the data. And the spread of scores should be roughly equal across all groups. We discussed this earlier. Data should be more or less homogeneous. You cannot take people with entirely different, already know that they are entirely different characteristics, and try and compare them. Apples to apples, oranges to oranges, right? So this is how ANOVA works. Are we clear on ANOVA? Any questions? No, for some of us, it'll be a little heavy. My apologies. I will try and simplify it as much as possible. Okay, if there are no questions, let's proceed. This is the easiest of these to understand. It's simple. Correlation. Are two things correlated? Correlation, there is a gentleman by the name of Kent Pearson who formulated this. He has contributed significantly to statistics. He came up with Pearson's R value. So basically, it talks about the relationship between two continuous variables, the strength and the direction. So R value can range between -1 and +1. So for example, one correction to be made, it's not linear regression. So an R value, if you're measuring test anxiety and academic performance, right? So these are actual numbers from real studies. They did a study of students and found that there is a -0.67 R value. That means it is in inverse relationship. So they tested anxiety and academic performance. Higher anxiety means lower academic performance. It may come across as common sense, but these are psychological studies which have been conducted to find out how much. 0.67 is not like 0.9. It basically talks about what is the relationship between two variables. An everyday example, again, this is from real research. This is one of the older research findings. This is common sense. It seems like common sense, but students who spend more time studying achieve higher exam scores. It is an R value of 0.82. That means it has a strong positive correlation. The 0.67 is moderately strong. It is an inverse correlation, right? Negative correlation. So the three types of correlation are listed. Positive correlation, as one increases, as anxiety, as studying time increases, performance increase, exam scores increase. That's a positive correlation. As anxiety increases, the academic performance decreases. That's a negative correlation. Sometimes you will find that there is no correlation. Here, it is important to understand that correlation is not causation. That means just because anxiety and academic performance are correlated, does not mean that anxiety will cause academic performance to dip. It only indicates it's an observation. That's all. You cannot categorically say in 100% of the cases it is like this, right? So what does correlation tell us? Same, what do you look for? You look for the strength and direction of the linear relationship between two continuous variables. Now here I explained it in one way. The reverse also you can take. As a researcher, you can study, as performance goes down, does my anxiety go up? Our results are due in a short while. So let us hope that our anxiety does not go up. I'm sure that some of our anxiety, especially me, is going up. So I am fulfilling this statistical model, right? So here, when you do this test, you will get an R value. Normally, as your statistical software, this can be done even in Excel. All these tests can be done in Excel. So even if you look on YouTube or look for tutorials, they will show you how to do it. It's quite simple and it's very intuitive. You can take any data and try it out if you have the time to do that. Again, the p-value is there. And here what we are measuring is your null hypothesis is there's no relationship between the two variables. The alternate hypothesis is that there is a relationship. And Cohen's benchmarks will tell you whether it is weak, moderate, or strong. So anything above 0.5 is considered a strong relationship. So the positive and negative only tell you whether one increases, the other one decreases. So if it's positive, both increase or decrease together. If it's negative, one increases, the other decreases. And of course, p-value is the main determining factor. So you will check the p-value first, right? Whether it is by chance or it is by design. And then you will check the R value to check how much something correlates with the other. So this is the formula. Don't get scared. It's a very simple formula. As you can see, it's basically the multiplication and division of a whole bunch of values. Here they've taken two values. There can be more values. Most of the time, this is done by a statistical software or in Excel. If you are required to calculate it, again, look through the R value. It will give you your variables, right? So sum of all the X values will be sum of all the anxiety scores. Sum of all the Y values will be the sum of all the academic performance scores, right? So then you do squaring, you multiply it by the number of values and all of that, and you will get an R value, right? So again, this is fairly straightforward. There are a lot of examples on YouTube to follow this. If anybody wants, I can share some calculated examples that you can follow along. If it will help anybody, I can share that. And finally, regression. The word looks very scary. Don't be scared. Regression is just prediction. The word is prediction, right? What does regression do? It predicts whether one variable, it will predict the value of a variable, of a dependent variable based on other variables. So there's linear regression and multiple regression. Just like one-way ANOVA, one factor, two-way ANOVA, two factors. Here you have one predictor, linear, it's called linear regression, and multiple regression, where many predictors. For example, you predict anxiety score based on sleep hours. What does your mind tell you? Anybody unmute your mic and tell me, without looking at what is your gut feeling in the relationship? If you have to predict anxiety score from the number of hours of sleep, what is your gut feeling?
Come again, what was the question?
If from your, without any statistical knowledge, without any data, if I asked you the question, does the will the anxiety, a person's anxiety level increase if their sleep hours decrease? What will be your answer?
Yes.
Now that
If you don't have an adequate sleep, yes, you get anxiety.
right. So see, anecdotally, by common sense, we are able to identify that. However, what linear regression can do is actually predict what that increase or reduction will be. That is the role of regression. It will predict the next value. If I reduce my sleep hours by 2 hours, how much will my anxiety increase in the long term? That is the role of regression. Common sense tells you that if our sleep decreases, anxiety increases. But by how much? That is the role of regression. So, in a psychology context, for example, if a person attends more therapy sessions, theoretically, his anxiety should reduce. Yes, it should. But we should, to add, make it predictable. How many sessions should he attend? 3, 5? These are calculations which are done in order to optimize the number of sessions, where a psychologist will say, I need 4 sessions with you. Right? These are all based on significant research. based on different conditions. For example, late onset psychosis, you will not treat in an elderly person, will not require the same amount of sessions as say CBT for job stress, for job related stress, right? Theoretically, you can use regression to identify these models. Now, a simple example is I've given the graph of how many umbrellas will be sold based on the millimeters of rainfall. It is raining today here in Bangalore. I don't know if it is raining in Chennai. But when the rainy season comes, automatically the number of umbrellas sold will go up. But by how much? If you have good data, regression can help you predict. And based on that prediction, a shopkeeper can even decide how many umbrellas to stock, right? So that is linear regression. So where it is only one predictor. In reality, we deal with multiple regression, where, for example, we predict the depression level based on two factors, based on what this person's stress level, which can be measured, and the person's social support, which again can be measured. Right? So depending on the number of people they have for social support. Like that. And an everyday example, for example, would be predict my monthly expenses based on my income and my family size. You could say roughly, as the income goes up, my monthly expenses will also go up. But if my family size comes down, like I move out into a separate, from a joint family into a nuclear family, and my income stays the same, my monthly expenses may come down. Right? Those are by how much is something that regression uses, and it gives us an equation for a best fit line. How best, what is the next possible value it tells you. Now, regression models predict an expected value, not a definition. Predictions are always estimates because there are too many factors. Right? The real world is full of various factors. For example, if depression level, stress and social support are not the only two factors that affect depression level. It could be neurotransmitter levels, it could be diet, it could be exercise. There are various variables, right? And so multiple regression often has to account for many things. And the more ingredients you have in the kutanjor, the more the chances of the kutanjor becoming something else, right? So that is the basics of regression. Similarly, what do we look for? We are looking for how different predictors influence the main variable, the y, the dependent variable. So we are asking, how does stress predict depression scores? Does stress and social support together, can they predict what the depression score will be? Right? So typically in a regression model, you are going to in a formula, it's a very simple formula. You'll see it here. It says y is equal to a plus bx plus u. Now bx bx could be b1x, b2x, b3x, depending on the number of factors, right? But what you're going to look at is how much you're going to see a slope coefficient called b, how much the dependent variable, that is for example, depression score, changes if the stress level changes by 1 unit. So if stress level goes from 2 to 3, how much does the depression score change? It may change by half, it may change by 0.3, right? So that is the slope coefficient. Explained variance, or R squared, is the percentage of variance in the depression score that can be explained by these predictors, right? How much of the change in depression score can be predicted by stress and social support? If you find that it cannot be, maybe there are some other factors. and of course, p-values for each coefficient. P-value is bread and butter for research methodology, right? So here we are deciding whether there is a predictive effect or there is no predictive effect, right? And there are interpretation has been given. If you have a positive b value, it says that is depression. In this case, a predictor, that is stress, increases the outcome, increases depression, right? More stress, more depression. Negative b value is more stress, less something else, less depression, right? Which may not be the case. So depending on what variables you are studying, you will see positive or negative. R squared tells us how much this particular factor is explained by the various variables. So 0.1 means there is a small predictive power, 0.3 medium, 0.5 large, and of course, like we said, p-value. So finally, the regression is the goal of the regression is to find the best fitting line, right? You are trying to minimize the error and predict what will happen next. If I do this therapy, my client's anxiety score should reduce by this much. That is the role of regression. If you have good data in a clinical setting or in any kind of counseling setting, if you have good data, you can use regression to analyze this. So the slide explains what are each of the terms. These we will need to memorize. Okay, Alan, you have given us so much information. My brain is overloaded. I cannot understand anything anymore. For that, this is a remedy. I put together a simple slide, right, which talks about the null hypothesis, the alternate hypothesis, what outputs you to expect from each of these tests, the typical values, right, and what they mean in how to interpret those values. I'll be taking tomorrow's class. If you want to go through these and you have questions, I'm happy to. Tomorrow's class will be much shorter because we're dealing with qualitative, which is much easier, and we have dealt with it in the previous semester. So if there are any questions about this, I'll be happy to take them. Now, to the exam perspective. Having analyzed the papers, every exam cycle has one question from both parametric and non-parametric stats. So parametric is every year, right? ANOVA, t-test, correlation, regression. They at least one 6-marker or one 10-marker is there, right? Non-parametric, which of course ma'am is handling tomorrow, is again very, very important. It takes these fundamental concepts to the next level and gives us more sophisticated tools as psychologists to move our research forward. So what is out of all this? What is the takeaway? You must study ANOVA one-way, two-way, t-test, correlation, and regression. One of these definitely comes. Alternate years, you get questions from what we will cover in the next class. That is day after tomorrow, God willing. So we might have problems if they give data with a example problem. They might give from ANOVA. They might give primarily a regression because that's the easiest to administer in an exam setting. So net takeaway, lessons 11 and 12 are very important. They cover about 20 to 25% across the years. So now we have come to the end of our class. Based on what you have learned, let's do a quick quiz, right? We want to measure stress before and after 6 weeks of yoga. Which test will you use based on what you remember? We can take a quick look at the tests. I'll go back to the right. Is it the t-test? Is it ANOVA, which compares different groups and factors? Is it regression or correlation? Which one?
No, it is t-test.
Excellent. Excellent answer. Thank you, sir. So it is the t-test because, and what t-test it is specifically?
The parametrical, we have to observation. We have to observe. Only then we can come to a conclusion after 6 weeks, right?
So,
yeah.
Correct. That is absolutely right. It is the what it is the paired t-test. Same group or same individual after a period of time. So that is correct. It is a paired t-test. Okay, next question. Depression levels in arts, science, and commerce students. 3 groups. Which one will it be?
Correlation.
You are studying depression levels in 3 groups. The clue is in that question. In 3 groups, you are studying one factor.
ANOVA?
Correct. It is one-way ANOVA, which is one factor across 3 groups. Right? Now, if you are studying the relationship, the strength and the intensity of a relation, or you're studying the strength and direction of a relationship between self-esteem level and anxiety, what test will you use?
Correlation.
Excellent. That is quite straightforward, right? So those are 3. Just a quick quiz. You guys did excellently. I had one more, which is predicting sleep quality from stress and caffeine intake, which is multiple regression. Why? Because you are trying to predict. The difference between ANOVA and regression is that ANOVA seeks to identify. Regression seeks to predict and create a best fit line. So these are the basics of predictive statistics. It is important to know these. Those of us who are interested in research, it's important to understand these at a conceptual level. I'm happy to share. I have examples of each of these calculated with data. I'm happy to share a one-pager with you along with this PPT. Any questions?
I just wanted to share a small example.
Yes, please.
Since we are talking about the anxiety. So in our office, we have the carom tournament of every year. And I even I'm used to play. At normal days, we have time to play from like 4 to 5. It's a game time. Those who are free out of work can go and have, you can use the game room for playing caroms or chess or whatever it is. So every year there'll be a tournament will be announced. Those who have interested, they can participate. So people will give their names. So there will be a lot of names who want to participate. So as the days come near to the tournament day, they will split the teams like 4 or 5 groups of teams. These 2 players will play with these 2 players. They will assign that. So once they see the email, the name list, they will come to a conclusion that like they are a little bit scared, anxiety. ஐயோ இந்த குரூப் கொடுப்பா இவங்க 2 பேர் இவங்க சூப்பரா விளையாடுவாங்களே. They'll come to a mindset like they are better players. So as the day comes on the tournament day, most of them will not participate. They will back off. They'll call off, and remaining who are exactly participating, who played at the normal day, their performance will reduce. I can see their hands are shivering while playing the carom. So even a good player is not able to achieve the champion. So it is like that. I have experienced for past 7 years. So even I'm one of the so for past 7 years I have been. It's not for Parametric or less. I'm the champion of my carom board in my office. But I learned for a couple of years. I was even my hand was shivering. But I learned why I lost the game in some tournament. But again, I learned that the anxiety is the main reason. So then I still see for past 7 years that some of are calling off, they are shivering, they are losing their game. But at normal time, they are able to beat anyone at any time. So this is one of the example where the ANOVA can be applied. So this is one. And when you when we are discussing about the uh, this, regression, as I said, the sleep, when you talked about the sleep, I was doing my night shift. So if I wake in between before the lunch or after the lunch, I'll have the headache. Definitely, I'll have a headache if my sleep is not until from morning 3 o'clock to evening 3 o'clock. I should not have disturbed sleep. If at all, if I get disturbed by 10 minutes or 15 minutes, whatever it is, surely I'll have a headache on the day. I have to take tablets. So I was like that. So it was being for a long time. So once when I was discussed with the other team members, I still remember her name. Her name is Hema. So she told that today I slept for a long time. So she told I asked her how long you slept until 8:30. 8:30 night 8:30 no morning 8:30 from midnight 3:30 to 8:30 she used to have a sleep. Then I asked her after 8:30 what will you do? I have my kid. I have to leave him to the school. I have to do things for my husband. Then I'll prepare my lunch. I'll pack my dinner. And I'll come to office. So I was surprised to see I used to sleep from midnight 3 o'clock to afternoon 3 o'clock, and she's just sleeping for two a couple of hours, and she's perfectly okay. At that moment, I decided that this is not the right way, and suddenly I don't know. From next day, I don't have that headache. So I was so much impressed with her sleep just for a couple of hours. She's sleeping and coming back to the same night shift, and she's also. I was a bachelor at that time. I don't have any other work other than the sleep. So I was surprised to see that, and that motivated me to come out of the headache. So it was gone extremely. And I don't mind about getting in between or after 4 hours sleep. Also, I'm able to continue the night shift. So these are the two examples I just wanted to quote here.
All right, thank you, sir. The first example, just those of us who are interested in sports psychology. Sports psychology is very heavily data reliant, uh, particularly prediction of player attitude, player anxiety. Sports psychologists rely on a lot of data to make decisions. So what you have seen in your office carom tournament is there is a scientific system to ensure to keep players at their top form. In professional leagues, there are specialized therapies. It's an excellent field, a very lucrative and high paying field as well. So what you are saying, sir, is very valuable because that is the basis on which even sports teams are selected. Player anxiety levels at high in tense situations or high stakes games are one of the factors which are evaluated in selecting players for teams. So that is a relevant example. Thank you very much, sir. Anyone else has any questions or comments? Feel free.
Sorry, I missed Naveen's example.
No, Naveen sir's example was from his carom tournament at office, which primarily he was talking about the role, certain aspects of sports psychology and the role of analysis like ANOVA and regression.
Okay, okay.
All right. If there are no other questions, just
So
for
crystal clear, very crystal clear, very nice. I mean, you made it like slow and steady wins the race.
thank you. That's
You
very
went point
kind.
by point, yeah. It's nice. I mean, the few minutes I attended was very nice, very clear.
Thank you so much. It was very kind.
Thank you, sir. Thank you. Thanks a lot, sir. Yes. Sir.
We will close this. I will send out the slides as well as some worked out examples I had prepared, and I'll see you in tomorrow's class, same time.
Okay, thank
Sure.
you.
Thank you.
Everyone, good night.
Thank you so much, sir.
Thank you.
You can stop recording, Alan. Alan?
Yeah, I will.
Okay.